I'm gonna put that on slow-mo, that would be terrible.
That'd be awesome.
All right.
Aren't you going to
Whoa. Here, take one of these. Okay. Okay. So here we go. Is this thing a polynomial function? No.
No.
Oh, wait a second, okay. On your real quiz, these are last year's quizzes here, a couple of them. I've kind of redone it a little bit, so I'm gonna ask you more, I'm gonna give you more than one polynomial, and you're gonna answer the question, but you're gonna answer the question the same way you do this one, only you're gonna have more tomorrow, more polynomials. This one has a couple of things wrong with it. I'm on the C side. It's on the C. What are some things that are wrong with this one? The answer is no, as you said. Why?
Variable and
You got a fractional exponent, and you have a variable underneath the radical, right? Those are no-nos. Okay? What are the other two no-nos? Negative exponent and variable in the denominator. Okay? We don't have those in this particular problem, but we can have those. All right, number 2. Remember that f of 2 equals 3 and f of negative 1 equals 15 means what? 2 comma 3, negative 1 comma 15. Right? These are ordered pairs. Your job is to write the equation of a linear function. All right? What do we do? Find the slope. Get the slope right. You've been doing it for years. Y minus y over x minus x. So it looks like this slope is negative 4. Right? So then what? Pick a point, doesn't matter which one, just pick one. And y, I use that first one, y minus 3 equals negative 4, x minus 2.
That's what I got.
So y minus 3 equals negative 4x plus 8. And y equals negative 4x plus 11. Linear function, I'll change that y into an f of x, and that will be my answer. Okay, guys?
Do you have to change the y back into the f of x?
Linear function. Last one. Here's some kind of parabola, and you're going to find all of this stuff. So vertex, axis of symmetry, direction of opening. Direction of opening is up. I heard that. Anybody who misses that needs a kick in the butt, right? Those are easy. They're always up unless there's a negative out here. All right. That is not vertex form. So how am I going to find the vertex if it's not vertex form? Negative b over 2a. So x equals negative b will be 8, and 2a will be 2 because a is 1. So my vertex is 4 comma something, and my axis of symmetry is x equals 4 because these always match. Now what? Plug the 4 into my problem. So 4 squared is 16. 8 times 4 is 32. So it looks like I'm going to get
Negative 15.
negative 23. All right, let's turn it over and practice one more time.
Confidently said 24.
The actual quiz is going to have more of these polynomial questions, but it will have a line question and it will have a parabola question, exactly like this. It'll just have a few more equations. All right, number one. Is it a polynomial? Why isn't it a polynomial? It has a variable in the denominator and it has a negative exponent. So what are our four rules? No x in denominator, no negative exponent, no fractional exponent, and no x under the radical. Right? Gotta know your four rules. Those are the four rules. All right, linear function. Negative 2 comma 5, 2 comma 13. We just did one like this. What's step one? Slope. 13 minus 5, 2 minus negative 2. Looks like this slope is going to be 2. Did you get that? Remember, tomorrow I'm not standing up here doing it. You have to do it by yourself. You getting 2? Pick a point. I'll pick that one. Y minus 13 equals 2x minus 2. Remember, this is x, this is y. Y goes with y. So y minus 13 equals 2x minus 4. Looks like I'm going to have f of x equal to, if I add 13 over here, 2x plus 9. Is that right? That's your answer. And finally, we're going to find our vertex and stuff. This time, our equation is x squared plus 12x plus 14. Which way do I open? Up. How do I find my axis of symmetry? Negative b over 2a. Did you get x equals negative 6? Which means your vertex is negative 6, comma. What's negative 6 squared? 36. Minus 72 plus 14. It's going to be negative something. Let's see. Negative 22. Okay? So this is what your quiz, it won't look exactly like this because as I said, I put in a few more, is this a polynomial function? Okay? All right, so put that away. Now we're going to go back to our notes. And we are starting 2-2 today. Before I forget, 1 week from today is the day we've all been waiting for. Opening day, Natalie. 1 week from today. All right, here we go. 2-2 is a very short section. We'll get it, it's only 1 page. We're gonna get that done today. So that homework will be due on Thursday. But I didn't really need a space, so up at the top, very top, I need you to write down these two formulas. If it is direct variation, it's y equals kx, where k is some number, okay? If it is inverse variation, it's y equals k over x. Those are the two formats that we need when we do direct variation and inverse variation, okay? So, A, y varies directly as x. That's that. Y varies directly as x, period. And then B is y varies inversely, so that would be over x. So again, y varies directly as x. So when you look at question C, it says E varies directly as the square of Q. So problem C does not have y's and x's. Problem C has p's and q squares. Do you see that? But they vary directly. So p equals k times q squared, because that's what vary directly does. One of your things equals k times the other one. That's what it means when you vary directly. All right, now D, what are our things? What are our letters? We have M, and we have A plus B. The sum, A plus B. This time, though, they vary inversely. So we don't say M equals K times that. That would be directly. That would be wrong. What do? M equals K over A plus B. If it's inversely, it's K over. If it's directly, it's K times. E, height and weight are two things, H and W. They vary directly. So what does that mean? H equals KW. It's either going to be K times W or K divided by W. If it's direct, it's K times. If it's inverse, it's K divided by.
Why K?
What?
Why the letter K?
K is, it's just a letter stands for constant. It doesn't matter. Everybody uses K, so I mean every book uses K, but it has nothing to do with anything. It could be J, P, L, M, anything. It's, you know how we use M for slope? Could be a different letter, we just always use M. All right, F. Now, F has a different vocabulary. F says proportional to. Right down above that, proportional to is the same as varies directly. When you say things are proportional, you mean they vary directly. It's just a different word. So y and x vary directly. So y equals kx. Question F is the same as question A. They mean exactly the same thing. And then G, rate and distance are my two things. It's either going to be R equals KD or R equals K over D. Which one is it? K over D. Yeah, K over, because it's inverse. Inversely proportional. All right, so It's real simple. If I said something like, age is inversely proportional to height. Your two things would be A and H. Since it's inversely proportional, it will be K over H. Directly, if I change one word, if I made that directly, then it would be K times H, right? Now, I want you to understand what these variations mean. So think about this for a second. I love bananas. Every week I go to the store and I buy bananas. The more bananas I buy, the more money I have to pay. Would you agree with that?
Yes.
So more bananas, more money. Less bananas, less money. That is direct variation. Both of the quantities, bananas and money, are moving the same way. If bananas go up, money goes up. That's direct. Now, if I drive 30 miles an hour to school, it takes me a certain amount of time to get here. If I drive 40 miles an hour to school, it takes me less time to get here, right? So more speed is less time. What's happening is as speed goes up, time goes down. That's inverse variation. Your two quantities are moving in opposite directions. Okay, that's the difference between the two lines, okay? All right, so now we're going to do a couple of actual problems. All we've done so far is set up equations. Now we're going to do a problem. All right, here we go. We're on 2A. Temperature is directly proportional to volume. So I have temperature and I have volume. Is it going to be T equals KV or T equals K over V? KV. It is directly proportional. We're not ready for the numbers yet. I wrote an equation for sentence 1. All right, now, if the temperature is 70, the volume is 30. Would everybody agree with that? So that means K is 70 divided by 30, or 7/3. Right, so here's sentence 1, here's sentence 2. What's sentence 3 say? Find the temperature if the volume is 20. Well, isn't temperature K times V? And since now I know what K is, can I find my T? Yep. So I'll just multiply. I'm getting 143rds, but you calculator addicts are probably getting 46.6 repeating. Right? That was easy. All right, let's try B. Volume and pressure. In problem B, what's my equation going to be? Is it going to be KP or K over P? K over P. So there's my equation. Always establish your equation first. If the volume is 200, the pressure is 40. So here's the equation you told me, and you were right. They gave me a volume and a pressure, plug them in. So K is going to be 8,000 if I multiplied right. You got a calculator? So ultimately then, find the pressure when the volume is 950. So I'm back to my formula. The volume is 950. I already figured out K was 8,000, and I gotta figure out P. Be careful. You gotta get rid of your denominator. So 950 P equals 8,000. So what's P gonna equal? 8,000 over 950. $8.42. These problems are so simple when you slow down and do them one line at a time. If you try to do it all at once, it gets overwhelming because there's a lot of numbers in there. But just slow down and do one at a time. Okay? 2.2 is due on Thursday. It is super easy. It won't take you long. You want to come to office hours in the morning, you can try and get out. Super simple.
Seriously, stop looking at her answers.
Look at 2.3. Oh my gosh. Mrs. Ford is expecting me to sketch this thing without a calculator. This is a no calculator exercise. I'm gonna sketch sketch this polynomial without a calculator. Okay? Now, before we start, there are two things. You already know these, but we're going to refresh your memories. In BFF land, you have x squared and you have x cubed. Any x to an even power, whether it's squared or x to the fourth or x to the sixth, anytime your x is to an even power, your curve, whatever it looks like, is going to have end behavior the same as x squared. What do I mean by end behavior? When I draw x squared, this side goes up and this side goes up, correct? Every even powered function is going to behave that way. Okay? The only time it will behave differently is if you put a negative in front of it. What happens when you put a negative in front of it? Then it's going to go down, down, right? So evens go up, up. This is even behavior, unless you put a negative in front of it, and then it looks like this. Always. Okay? Now what about x cubed? X cubed doesn't look like that. On this side, x cubed is going down, but on this side, x cubed is going up. So for all odd powers, x to the fifth, x to the seventh, x to the 11th, any odd power, they're going to start down and end up. Always. Unless you put a negative in front of it and then it turns it upside down. Okay? So that's the first thing you've got to get solidified in your head. Okay. Now, let's look at this guy. If you multiplied it all out, and please don't, but if you multiplied it all out, what would be the power on x, the biggest power on x? X cubed. This is an x cubed. So this is how it's going to act. This is how cubes act. All right, so it's gonna start down here somewhere. And it's gonna end up here somewhere. That's what they do. Now, what's it doing in the middle? Well, these parentheses are very, very important. If you had those factors on a number line, I would say to you, there's 3 dots on this number line. Where would you put the 3 dots on the number line? -1, 2, and 3. Put them right here on the x-axis. -1, 2, and 3. Those are x values. Those are the zeros of the polynomial. Those dots have to be connected with a nice smooth curve. So I'm going to start down here, because this is where cube starts. When I get to that point, I'm going to go through it, but I got to connect to this dot. I got to go through it and connect to this dot, and then I got to end up there. You just graphed it. That's it. Now, you're thinking to yourself, how do I know how high this goes? You don't. That's a calculus problem. We just know somehow it's connected. We don't know how low that goes. We just know it's connected. We're sketching. This isn't going to be a perfect graph. By hand, it's the best I can do.
I have curiosity, could you just go straight across that line? And
You
go-
can't ever go straight across. Polynomial functions are curves. There will be no straight lines. There will be no jagged edges.
Last year in academic, algebra 2, they were like bounces.
Yep, we're getting ready for that.
Okay.
We haven't done that yet. We're gonna see it we're gonna see it soon. We're gonna do one more like this. All right, guys, everybody paying attention? All right, let's look at B. Okay, first thing you're gonna do is put dots. Technically, they're called zeros, x-intercepts. We're gonna put them at -4, +2, and -3. Then we're gonna pay attention to how many x's we have. If we multiplied that all together, it's another x cubed. So it's gonna look just like this.
Wait. Why? This is the 3 positive No, I do that.
Or like,
Wait,
what's
what's
the
the
S?
question? What?
Well, in the first one, you were like, if the 3 was negative.
No, no. X cubed, stop. Sammy, listen. X cubed, if I multiply that out, it's gonna be x cubed plus a bunch of stuff. All that matters is that's x cubed, and that's a positive. There's not gonna be a negative in front of that. There can be negative zeros. Sure, that has nothing to do with the direction of the curve. Okay? What matters is when I FOIL that out, I would have positive x cubed. And positive x cubes look like this. So, starts down here. When it gets to that point, it's gonna go through and connect. Go through and connect and shoot up into space. Okay? Problem C has some similarities. If I FOIL this out, multiplied it all out, what would I have? X to what power?
Next to X plus 1 is mine. Or no. Can't.
Kids, if you multiplied x plus 1, and x minus 3, what would you have? X to the what?
X to the third.
When you have x to the third, under 3 x's up there. So this is another x to the third, which means it's gonna look just like that. Some variation of that, I should say. Now, what's the difference?
There's like
The difference is, I have an intercept at -1 and an intercept at 3, but that's it. Right? Now, it is still starting down here. That's how x cubes do. Now, because that factor is squared, when it hits that 0, this is the 0, -1 is what came from this parentheses. When it hits that 0, it bounces off. Now, think of it like this, you guys. Whenever you have x squared, what shape do you have? Parabola. You got one built in here. You got one built in to the problem, a parabola action built in. So it's gonna come up and bounce off because that has a squared. It's gotta turn around somewhere and come back up because remember, the dots have to be connected. What's it gonna do when it hits that one? Keep right on going. How come it's not bouncing? Cause it's not squared. If it's not squared, we just go right through it.
Oh, no.
All right. How many x's do we have in this one? 4. 4 is an even number, and evens act like this. So this one is going to start up here and end up here. That's what evens do. So I got 2 and -3. Would everybody agree those are my intercepts? Guys, you with me?
Yes.
Now, it's even, so I'm starting up here. So I'm gonna come down to this point. Now, what do I do when I get to that point? My choices are go through, bounce off.
You bounce,
I bounce, whoops, I bounce,
and then you bounce again.
because that is squared. So here I go, bounce off, come up, gotta connect. And what happens here at 2? It bounces again. And I end up right where I was supposed to end up.
Whoa.
So when they're even, you start at the top.
Huh?
When they're even, you start at the top.
This is end behavior for evens, yes. We talked about that first thing, Jerry, so I
Right there.
wrote it down. Evens are this. Up. Oh my gosh, look at E. When you guys go home tonight, and mom and dad sitting at the dinner table say, what did you learn in school today? Whip this out on a napkin. They will be impressed. How many X's do I have? 5. 5 is odd. Odds act like this, right? That's odds. So, I know I'm starting down here and ending up here. I have an intercept at -1, an intercept at 2, and an intercept at -5. So I know I'm starting down here. How do I know I'm starting down there? Okay, I got my phone. I got to check on something. I got a daughter in
Florida.
Florida. Did I tell you that already?
Yeah.
So I'm panicking. Okay. It's only a category 4 now, so only a category
It went down.
Yeah, it was a 5 yesterday. That's when I was on the phone screaming at her to come home. Don't worry. Okay. All right, so -5. I'm coming up from the bottom, right? Because it's odd. Now, what am I doing when I get here? Remember, that came from this factor. I go through and connect to this one. That one came from this one, so it's gonna bounce off and connect. That one came from this one, so it's gonna bounce off and shoot up. All right. Just when you thought you had things under control, throwing something different at you here.
Do you need something to come up and, solve it?
Not this one, you gotta talk about it first, because this one's a little different. What is different about this one? It has a cube factor. Okay? Now, first of all, let's count our x's. How many do we have? 4. So we know we're gonna start up here and end up here. That's what fourths do. Okay? So I'm gonna come down, and I'm gonna pick this guy up right here. And what am I gonna do when I hit that point? Now that point came from this factor. So what am I gonna do?
Through.
Right on through, right? Just right on through, straight through. At some point though, it's gotta turn around and head back up. Would you agree?
Yeah.
Now, when it gets to this, because that factor is cubed, it's gonna behave like a cube. So it isn't going to go straight through, it is going to squiggle through. Remember your cubing function, you guys? Remember how it did a little squiggle there? If you have a cube factor, you're gonna squiggle through that factor. He wants to know, how do you know if it bounces or goes through? When does it go through? When does it go straight through? When there's no power. When does it bounce? When it has a square power. When does it squiggle through? When it has a cube power. Okay? All right, here we go. Let's talk about the fact that when you put a dot on the x-axis, it comes from a parentheses with an x. Gotta have an x. No x, no dot. So that -2 is not gonna have a dot. That -2 I'm gonna ignore, except for the fact that it is negative, because that means my picture is going to be upside down of how it normally would be. But the dots are going to be at -1, at 3, and at -2. That's where the dots are going to be. Because parentheses get dots. X's, I should say X's get dots. So every X is going to be associated with a dot. Now, how many X's do I have? 4. 4 is even. This is what it should look like. But what?
But it's
There's
flipped
a
upside down.
negative, So it's gonna start down here. A normal, even power, x to the fourth, is up. Put a negative in front of it, and it is down.
Wait, so the two just.
The two I ignore. The two I ignore.
The whole time?
Yep.
Oh,
If I'm plotting points, I have to take into account, but I'm not plotting points. The negative matters, the two does not.
Man, I used to.
No, school's out in, 12 minutes. Is it, are you gonna explode? I mean, alright. So -2, I hit -2. Now, what do I do when I get to -2? But I gotta connect to this guy. What do I do at -1? And connect to this guy.
then it bounces.
What do I do at him? Then it
Just like that.
bounce off.
What?
And sure enough, guys, where did we say it had to end? Down, and it does. It does, down. All right, take a second, and you and your neighbor work on this one, and I will have someone come up and put this one on the board.
Let's just log in, Davison. Ow.
If you feel
Let's log in.
Take a minute.
Can we stop this actually?
Oh. Yes, where is it? Oh, I was right. No, but it's upside down.
Yeah, because it's
Quit talking about it, you won't have to go. Look, I need somebody to put it up, come on. All right, Sammy's gonna put it up here on the board. I did it. And we're gonna talk about what she's got up here, I'm sure it's right. But, what are some things that are going through your mind?
It's upside down,
Okay, David sees a negative.
but it's positive.
So whatever it is, it's gonna be upside down of what it should be.
It should, like do that.
Jameson says it must have an even power, if you believe that. How many X's do we have up here, guys?
6.
6. This is what it should look like, but as David said, it has a negative, so this is what it's gonna end up looking like. So notice that Sammy came up from the bottom. That's exactly what she should have done. And she's ending at the bottom. Perfect. What happened in the middle? Well, she's got zeros at -2, 1, and 3, right?
Excuse me.
And she came up from the bottom and she kind of squiggled through that. Was that the appropriate thing to do? Yeah. So she squiggled and connected. When she got to that one, she just went right through? No, she went right through that one. And then she connected to this one and bounced down. Beautiful job.
Good job.
Now, I want everybody to get out your calculator. And we're going to graph this on our calculator.
No, I didn't. I figured out how to use my calculator.
Are you okay? To get an optimum picture. Go to window right now. Everybody go to window right now. X min, -5. X max, 5. Y min, Y min can be -10, and Y max should be of 25.
Whoa.
So y min -10, y max 25.
Do I clear out my one?
Type in your equation. So -1/3.
Y min is what? Y min is -10. What about y max?
X plus 2.
What's y max?
What's one max? 25. Oh my gosh, that's so pretty.
It's not so pretty.
I should have dropped my y min down a little more, but do you see a squiggle? Definitely. You see it going up and then coming down and through and then bouncing off? Yep. So she did a great job. Very nicely done. Very nicely done. Okay.
Yeah, I got an error syntax.
Syntax errors mean you typed in something wrong. It's like a grammar mistake. You typed in something wrong. Make sure that you're putting this in as a minus and not a negative. Make sure you've got parentheses open and closed where they need to be.
Look at that.
It's like not going.
All right, one more problem and we're done for today, okay? One more.
I don't know how to help you, bro. I have a different character. Go to Mr. Mike's. He knows everything about that.
Last problem, 2A. The picture is drawn
This sounds so good.
and you are gonna write the equation. So in other words, we're backwards of how we've been doing it. I've been giving you the equation, you're drawing the picture. Now you're gonna build an equation. So y equals. Alright, so let's start with what we know. How about parentheses? I see 3 dots. So there's gonna be 3 parentheses. And what's going to be in those parentheses? X plus 2 minus 1 minus 3. Now here is a tricky part. Pay attention to the picture. That one goes through. Oh, that one bounces, which means what about my equation? X minus 1 is going to be squared, right? How about that? Well, there's something not quite right about it.
-2 in front.
I need a negative something in the front. Do you remember yesterday when we were writing equations of parabolas? We had that mystery number out in front. I think I called it n. We have one here too. Remember, one of our problems a minute ago was a -1/3 and it was like -2 or something. I don't know what that number is. But I have a random x and y given to me. So what am I going to do? Plug in that random x and y, and that's going to tell me what my n is.
Wouldn't it be negative n?
No, just put n. It'll come out negative. The number will come out negative. So I'm going to put in 2 for y and 0 for my x's.
Oh, everyone's done
Everybody all right? Y is 2, and then all of the x's have to be 0. So 2 equals n times what? 2, 1, and -3. So 2 equals n times -6. So n is 2 divided by negative 6, so what's my n? Negative 1/3. And there's your equation. So it's just like we did yesterday, just bigger. And we will stop there.
Don't forget about
We have a lot going on. 2-1 is due tomorrow. 2-2 is due Thursday. And we have a little quizzy poo on
I'll be ready for the quizzy poo.
Thursday.
I'm going to do it tomorrow, but I don't see you tomorrow.